Having a Nobel Prize awarded to Liz Blackburn gives us all a chance to reflect on the importance of all of that work and what it means for humanity. One of the important things here at UCSF is a long tradition and love for basic science. And basic science is asking very basic questions about biology well before anyone knows why it matters. So one of the wonderful things we're celebrating about the work on telomeres and telomerase is it started as a basic question about how cells divide and why they stop growing. And so when the work was started, no one knew what the applications would be or why it would be important or that it would lead to a Nobel Prize.
It's exciting to have this kind of research recognized. Well, this is physiology and medicine, and it's to do with the basic research that we did related to the ends of chromosomes and how the ends of chromosomes carry all the genetic material and how the ends of the chromosomes are protected. And so my early work had discovered the molecular nature of the DNA that protects the ends of chromosomes, and then the collaborative work done with Carol Greider and with Jack Szostak brought a new understanding of how those ends are replenished by a new enzyme. I was interested in the ends of DNA molecules, in other words, the ends of chromosomes, and there were some molecular tools to start asking questions in a molecular way about the DNA. So I started that in the late 1970s.
I think many of the major discoveries in recent times have come out of basic research, where we learned how a very fundamental process is working, and we need this understanding of how a cell accomplishes its various tasks in order to figure out what can go wrong with it. That if we manipulate it, or if we learn how to manipulate it, we can actually do something about cancer or aging or stress situations.
What became important was the ability to do research in a medical school setting, because I have collaborations with colleagues who are interested in human disease and human health and how we maintain human health. And so that juxtaposition of basic science and medical and clinical interest is something that was and is a very strong attraction of UCSF for me.
We are just so excited about the environment we're able to create here at UCSF. It's just phenomenal to have colleagues like Liz who are doing fundamental basic work, but to be in an elevator, in a cafeteria, in a hallway, in a meeting with clinicians who are struggling with patients with disease, and for that aha moment where you can connect the dots between what Liz and colleagues like Liz are doing in the labs to what we're experiencing when we're looking after patients, and to realize it doesn't happen overnight. Obviously, Liz mentions that this didn't fall into her lap. It was a hunt. It was a long search to connect those dots. But once they're connected, the light bulb goes off, and the excitement about a place like this just explodes.
The fact that Liz Blackburn's work on telomeres was so important for science is also important that it's in Northern California here at UCSF and was quickly focused on by the surrounding biotech industry and by this atmosphere, this secret sauce that it seems to be pervasive in Northern California, an atmosphere of innovation, of entrepreneurs, and of really fantastic science.
Well, the wonderful thing about basic research is when you say, what would you like to see is the future? If you can see it, it's already boring. The exciting part is what you don't know is going to happen. I think that's what's so wonderful about biology. It's so complex.
I think it is a reflection that outside the walls of UCSF, people looking in can see the excellence of the work and the work that contributes to advancing health worldwide.